I'm going to Dominican Republic in July.
This is us. I watched 3 episodes and I'm like, but I haven't cried yet.
She's like, our mom will be in her room sobbing watching that show, but are you okay?
Yeah, This Is Us. It's my cry show.
I haven't watched that yet.
I just started. My sister is so addicted to it and I'm like, okay, she's smart, she's pretty, she makes really good money. I gotta do everything she does.
See, I hate those people.
Well, she's my younger sister, that's the
Oh,
bad
I'm
part.
not,
She looks up to me and I'm like, why?
all right, y'all. I think I hit record. Let me double check. I'll do like I did. Okay, there we go. I had 1 or 2 people email me this morning and ask me to record, so here we go again. At the end of class, we'll talk about, but we're definitely finishing chapter, whatever I'm on, chapter 4. We'll definitely finish that between today and Thursday. So we'll talk about when we want homework due for 3 and 4, when we want the test to be done for 3 and 4. We'll talk about all of that by the end of class today. I did send you an email sometime last night, it was between maybe 9:30, 10 o'clock, talking about when the hub would be open over spring break. So it will be open every day next week. Not normal hours, they'll be open in the afternoon a couple of hours, a couple of days they'll be open in the morning a couple of days, they just won't be open their full hours. We're going to give our tutors a break. Where we left off was 4.2, and if I pull up, I don't need my email anymore, if I pull up the study guide for 3 and 4, we did quite a bit in 4.1. We did all the mean, median, and mode, what I need to make on the next test, GPA stuff. Now we're doing 4.2 stuff, okay? And there's not that much in 4.2. And then we go back to 4.3. So 4.2 is not going to be calculator stuff. 4.3 is going to go back to the calculator. So 4.2, we're talking about graphs and stuff, and that's what we're going to be doing right now. And then we're going to go back to the calculator stuff. And remember, even if you don't have a calculator, they'll give you a calculator when you take your test. And if you need a calculator to do your homework, go down to the tutoring room. They'll let you borrow a calculator to do your homework. All you got to do is go down there and say, can I borrow a calculator? I've got to do some 107 stuff. And they'll let you borrow a calculator so that you can knock that out. All right, so 4.2, we started talking about this, and I'm just bringing it up just to make sure we can remember what we're doing. It was at the end of class. We said that if you connect the dots of the histogram, you're going to have these humps. And if you have one hump, it's one mode or unimodal. 2 humps is bimodal or 2 modes. 3 modes is trimodal. And if all of them are the same, there's no modes. Everything's the same. It's a uniform distribution. That's what we started talking about. And this is just the wordy version of that. And then this is where we ended class. We started talking about if something was symmetric, if it was left skewed, or if it was right skewed. So if you have the left side and the right side exactly the same, it's going to be symmetric. And the way that we talk about this statistically is I just slammed the door in your face, Jane. My bad. When we talk about this statistically, we want to know where the outliers. So if you have outliers on both ends, and y'all, you probably heard teachers say, I teach on the bell-shaped curve. That means if this was A through F, the teacher that teaches on the bell-shaped curves gives very few A's, a couple of B's, lots of C's, a couple of D's, and a couple of F's. So if they teach on the bell-shaped curve, then the majority of their students make C's. You barely get an A, you barely get an F. That's the bell-shaped curve. Okay? This would be if you were going from A to F, this teacher would be a harder teacher, or everybody fails the class. Not many people make A's, B's, or C's. Everybody makes D's or F's. So the outlier is going to be the A's and B's. Not many people make A's or B's. So this is going to be less skewed because your skewness is on the left. You don't go by where the hump is. Remember I said if this was like a rope, it's who's holding the rope. So if I had a rope and I went, it's who's holding the rope, not where the hump is. Right skewed is if I was going from A to F, A's and B's, this would be like an easy teacher. A's and B's, Not many people make D's and F's, so this is right skewed because that's where the outliers are. So you would be holding the rope here going like that. We cool? And we're going to do lots of examples today with the skewness. And I drew those examples saying if you were going from 0 to 100, a lot of students would make, well this time I went 0 to 100 that way. For this one, the majority of the students failed the class. So this would be a hard teacher if I was going from 0 to 100. This one would be an easy teacher because all the grades would be A's and B's. So this would be a lot of F's and D's, and this would be a lot of B's and A's. We good? Okay. Now, we talked about line of symmetry. Lines of symmetry can look like anything as long as the left side and the right side pretty much look alike. We've all talked about butterflies or hearts or whatever. We know what symmetrical means. Now, when you have the hump, and let me do a highlighter. If your outliers are on the left, that means your mean and your median are pushed to the left. If you're right skewed, meaning your outliers are on the right, your mean and your median are pushed to the right. If you're symmetrical, that means everything is in the middle. So remember that basketball problem we did the other day where 4 people didn't get an NBA thing, but 1 person did? So that would be like this one. Everybody got a 0, and that other person got like a $5 million NBA thing. So it pulled everything. You with me? So if it's left skewed, the mean and the median are pulled towards that value. Okay? So if it's symmetric, your mean, median, and mode are all going to be the same thing. Because it's like the outliers cancel each other out. You have a low score, you have a high score, they cancel each other out. So your mean, median, and mode are going to be the same because the outliers cancel each other out. Now here, everybody was making a good grade, and then there was a 1 person that screwed it up and brought down the class's average. It's like when I tell y'all your average on your first test, I may have 1 or 2 people that aren't coming to class anymore that I had to withdraw. I'm not going to put those zeros in before I give you your average because that's going to screw up the class's average. That's an outlier. It's going to make the class's average be a lot lower than it really is. Here, everybody was failing that test, and then there's that 1 smart person who made 100 that's going to bring the class's average up. Does that make sense? So the outlier skews the data. It ruins the data. All right, so now, and let me cover up so that we can talk about these. So this is what we're going to be talking about. I'm going to give you a situation, and we're going to determine, is our situation just based on a problem, is it going to be symmetric, left skewed, or right skewed? And the way we're going to determine this is we're going to determine where should the outliers be. Okay? If it's symmetric, that means we're going to have outliers on both ends. If it's left skewed, that means we'll have an outlier on the left. If it's right skewed, that means we'll have an outlier on the right. So we're going to look at the situation and say, where is my outliers going to be? So, symmetric, left skewed, and right skewed. So it's all about where the outliers are. So for the first one, it says heights of 100 women. And you're going, I don't know how tall 100 women are. 100, what the average height of 100 women is something. Maybe 5.5 feet tall. I don't know what the average height of a woman is, but it's something. Let me just say 5 feet 5 inches. I don't know, I'm just picking something. So do you agree most women are somewhere in that range? See how I use the word most women? That's the mode. That's where my hump is going to be. So we've got to think about the outliers. The outliers are where the people are going to be at either end, the oddballs. So could there be a really short woman in that group?
Yes.
Oh, yeah. Could there be a really tall woman in that group? Oh, yeah. So we can have outliers in both ends. So because we can have outliers in both ends, what kind of situation is this going to be? Symmetric. You with me? Family income. So the first one is symmetric because we have outliers in both ends. Symmetric. We can have some short women, we can have some tall women, but most of the women are going to be something in the middle. Family income in the United States. Okay, I'm going to put this one kind of down here. So we're talking about income. We're not talking about how much you owe, because people can owe lots of money. We're talking about what you can make. So, what is the least amount that you can make?
0.
0. Now, we can go all the way to a millionaire, a billionaire, a gazillionaire. But can we go into the negatives? We can't make negative amount of money. You with me? So if I had a number line where this was 0 and this was really big and this was really negative, okay, do you agree I cannot go to the negative side? The most that I can go is on the positive side because I can't make, this is making money, not losing money, okay? Now, where is the majority of the people going to be? They're going to make money, okay? Now, if this is a millionaire, and let's say this is $100,000, do you agree that most people are either broke to 100 grand? Whatever that amount would be.
Yes.
Now, I can't go past broke. I can't make the negative amount of money. Can I have an outlier to the right? Oh yeah. We're not those rich people, but we know they're out there. So we can have an outlier down here. We can have a millionaire or a billionaire or whatever. But we cannot have an outlier on the other end. It's got to stop. So what kind of skewness is this one? This one's going to be right skewed because it cannot go all the way to the other direction. It's got to stop at 0. Does that make sense? So if I come down here, it says it's right skewed. All right, now let's go to C, and we're going to do lots of these. Speeds of cars where a visible po-po. Visible po-po. Now, I come through Darlington by the racetrack every morning. And if you've ever gone through Darlington, it's like going through Aner or Macbeth.
Oh, yeah.
They park right there. Okay?
Yeah.
Now, this is different than not seeing a po-po. It says visible. Now, I have some people say, well, I don't know what the speed limit is. I don't care what the speed limit is. It's whatever's posted on that sign. So, do you agree that most cars, if you see the cop, you're going to go within 1 or 2 miles above or below whatever it says? Okay? Now, we've got to think about the outliers. Is somebody going to go?
Yeah.
Okay? Now, when I say fast, if the speed limit's 50, is somebody going to go 75?
Yes.
If they see the cop,
No, not unless they have a death wish.
correct. If they may go a little bit over, but they're not going to go 75 or 85 if they see the cop. Now, is there somebody that's going to see a cop and like go turtle slow? Yeah, which is screaming, I made you guilty. But they're going to do it. So, visually seeing a cop, there's not people that are going to go super fast, but there are people that are going to go super slow. Now, I'm not talking about 1 or 2 miles over. I'm talking about 15 or 20 miles over. So what kind of skewness is this one? This one's gonna be left skewed. Does that make sense? So this one is going to be, drivers usually slow down when they are aware of a patrol car. Few will exceed the speed limit, but some will tend to slow down too much. So this one's gonna be left skewed. Make sense? Some of these are gonna be super easy, some of these are gonna be a little bit hard, okay, but we're gonna do lots of these. I just wanted to give you some to look at. All right, let me make sure I got all that in there. I think I did. Let me double check. Oh yeah, that's just my bar. Okay, now, this one gives us a histogram. We all know what a histogram is. That's when our bars touch. And the bars touch because when one bar ends at 299, the next bar starts at 300. So this says, here's a histogram. The first thing it wants us to do is draw a smooth curve to give me the general features. So the first thing I'm going to do is I'm going to connect the dots. So I'm going to start out at the ground, and then I'm going to kind of connect my bars, and then I'm going to connect it back to the ground. So that's the first thing it wanted me to do. The second thing it wants me to do is it says classify the distribution according to the number of modes. So how many modes would you say this has? I would say that it has 2 modes, only because this last one is really not even like a speed bump. You with me? It's not even like a whoop, like not even one person said that. Where here, 35 people and 60 people. You with me? So I would say 2 modes. Then it says, tell me the symmetry or skewness. So we're going to say, is it symmetric? Is it left skewed? Or is it right skewed? So does it look something like that? Does it look like that? Or does it look like that? So if you had to look at the overall, what would you say? Think about where your outliers are. Think about if it's cattywampus or not. So does it look like I can cut it in the middle and my left and my right are like mirror images? So do we agree it's kind of not symmetrical? Okay, so now we need to say, is it left skewed or is it right skewed? Why do you say right, Ashley?
Because most of them, like, people are on the right side, whereas there's not that many anymore.
Your outliers are kind of where you're holding it, not where the humps are. And you're right. Pretend that I'm holding this right here and I'm going, see where I'm holding it right here? And I'm doing this and my humps are kind of, like my waves are kind of over there and I'm holding it right here. So it's not where my humps are, it's where I'm holding it as my outliers. And it's not a whole lot of skewness. It's just kind of like it's pushed, like the mountains are pushed that way just a little bit. So it's a little bit skewed, not a whole lot. So because your outlier's on this side, that's your right hand, so it's a little bit right skewed. Okay, so I would say, what color did I write that in? Red? I would say slightly right skewed. Because these are going to be my outliers. Not many people scored 100 or 110. A lot of people scored in the 50s, 60s, 70s, 80s, and 90s, but not many people scored. That's where my outliers are. Okay? All right. Oh, this one's good. Yeah. You know it's jumpy if I say that. Okay. Let me pull these up so I have a little bit of room. Okay. They didn't give me data. They just gave, they didn't give me like numbers. They just gave me a little bit of data. In a recent year, professional baseball players had salaries with the following characteristics. The mean was $3.2 million. The median was $1.15 million, and the salaries ranged from $400,000 to $33 million. So we know that if we're looking at baseball players, the cheapest baseball player we could afford is $400,000, heaven forbid. Gosh. I know. 33 million was the highest paying person. The median, what does median mean? Middle. So if I take the lowest ball player and the highest ball player and put them in order and come in from either side, that's the middle ball player. And mean is when I add them all up and divide by how many ball players I have, which is 817. So, if I take that data and let's draw it for a minute. We don't really have the data, but what's that?
Stick man with a travel?
That's my ball player.
Oh.
So, my sad ball player is going to be 400,000. All the way up to 33 million. So, I've got to, I can't just count randomly, I have to have it in scale. So, I'm going to do 0, let me do it like on a number line. Let's do 0, let's count by 5 millions. 5 million, 5, 10, 15, 20, 25, 30, 35 million. 5, 10, 15, 20, 25, 30. I wish I could count my salary in terms of millions. That would be nice.
You can if you do pennies.
True, true. So, if we were to mark all of these on here, the lowest and the highest, so the highest would be 33 million. Do you agree, which would be about right there? Now, if this is from 0 to 5 million, let me break that down. This would be 1, 2, 3, 4, correct? So 400,000 is going to be halfway between 0 and 1. Because that 400,000 is like $500,000. So I've done my lowest score and I've done my highest score. Now, my median is a little over 1 million. So that's going to be about right there. My mean is a little over 3. So 1, 2, 3. So my mean is a little over 3. We good? So, let me move him and him for right now. So, when we first started talking today, we said that your mean, median, and mode, see how all three of those are under the hump? All three of these are under the hump, and all three of these are under the hump. So no matter whether it's left skewed, right skewed, or symmetric, all three of those, mean, median, and mode, are under the hump. Okay? They're the same if it's symmetric. The mean and the median are to the right if it's right skewed, and the mean and the median are to the left if it's left skewed, but all three of them are under the hump. So if I come back to this baseball problem, I know that my mean and median are going to be under the hump. It didn't give me the mode, but I know that my mean, median, and mode are going to be under the hump. So I'm going to put both of these somewhere under that umbrella or that hump. And then I'm going to connect it to the dots, which are my outliers. So if I connect the dots to here and to here, can you immediately now tell what kind of skewness this is?
Yeah.
And that's what question A says. Question A says, describe the shape of the salaries. Is it symmetric, left skewed, or right skewed? This one is going to be right skewed. So even though we have a person making $33 million, what do the majority of the ball players make? Under $5 million. Okay? So, yes, he makes really good, but all the other data, the mean, the median, and the lowest salary tell us that he is definitely an outlier. The majority of the data, the mean, the median, we didn't know the mode, but we know the mean, median, and mode are all up underneath that umbrella. So it's right skewed. All right, now let's take this same data and let's look at part B. Part B says how many players had salaries of $1.152 million or higher. So 1.152 million describes the median. what did we say the median means?
Middle.
The middle ball player. So, let me copy this and slide it down for just a minute, and let me get the original problem. So, now they're telling us, how many ball players do we have? 817 ball players. So if I take 817 players and I line them up from the cheapest ball player to the most expensive ball player, the middle ball player is going to be $1,152,000. So we want to know how many ball players made higher than this. So this is what I want to know. How many people made higher than that? How would I get this? If there's 817 people in all, half of the people made higher. So what am I going to do? Come on, I know Ashley knows. If I have 30 people in this class, and half of you make more than $5,000, how many of 30 people make half of you? 15. 15 of you make half. 15 of you make more than $5,000. 15 of you make less than $5,000. Y'all with me? So if we have 817 players, do you agree that half of those 817 players are going to make above that?
Yes.
And half of those players are going to make below that. So we already know what this player makes. We know his salary. I am worried about the ones above him. So if there are 817 total players, okay, now, my calculator's screwing up, but it's okay. So then y'all are going to tell me 408.5. You can't have half a player. So then you're going to say, okay, should I round it up or should I round it down? Mathematically, you're going to round it up because Ms. Cooper says you got to round mathematically. So if you round it to 409, let me load this again. If you round it to 409, watch what happens. Let me load this one more time. Because mathematically, 408.5 does round to 409. There we go. So if I do 409 above the player, zero doesn't work. 409 people above that player and 409 people below that middle player. What's wrong?
You got one player too many.
I got one player too many because I only have 817 players and now I have 818 players. So what do I need to do?
Got it.
So how many players make above 1.152 million?
408.
Okay, so then you got to convince yourself that's the right answer. So right now you're saying you think that 408 players make above. So what? They didn't ask me, but how many players do you think make below?
408.
And here's the extra player.
Exactly.
So if 408 players are above the average, and 408 players are below the average, and then you have one person that's making the middle, there's your 817. So that half a player, they counted half a player on the big part and half a player on the small part. Y'all with me? So what's the answer to this problem? What was even the question? We started it like 45 minutes ago. How many players had salaries of 1.152 million or higher?
409.
408.
No, because one made 1,152,000 plus.
This is the 1 plus the 408, so it is 409. If it just said how many people made above 1.152, then it would be 409. 408. Y'all with me? Don't y'all, then this is when you say, is this on the freaking test?
This is all in the tricky wording.
It is. So this is when we go over here and we say, is this on the test? If I give you a histogram like the geyser problem just a minute ago, and I say, given a histogram, determine the modes. That's when you connected the dots and we saw there were two modes. And then it says determine the skewness or the symmetry, and that's when you have